Here is our big fact from section 1.6. Recall from class that if you try plugging in 0 for u in sine of u over u, that you get 0 over 0, which makes things difficult. Usually when we get 0 over 0, we're expecting to be able to factor and reduce the fraction. Here, that is obviously not an option, and as a consequence, this little fact is a big fact because it's difficult to show without a certain amount of messing around. If you assume the first fact is true, then it's fairly easy to show that this second fact is also going to be true, that the limit as u goes to 0 of u over sine of u is also going to be 1. This follows from some fairly simple algebra, since u over sine of u is just 1 over the first formula. We can replace the original limit with 1 over the limit of sine of u over u and quickly get that the limit has to be 1 over 1 or 1. Okay, so let's look at a basic example. Here's something pretty typical. I'm going to overdo it here a little bit with the algebra, but the main trick is going to be that I need to have you isolate that sine of u over u algebraically before you use that big fact. This is going to tend to require that you take your original fraction and write it as a bunch of littler fractions multiplied together and do it in a useful way. In order to have a sine of u over u in this particular example, the downstairs x needs to have a multiplied 3x in its place. So I'll try to be clever by multiplying that x downstairs by 3 and then compensating elsewhere by multiplying that 3 into the numerator. Now if x is going to 0, then that means that 3x is also going to 0, and I'm set up to use 3x as my u. Now as x goes to 0, 3x is going to 0, and I see that the sine of 3x over 3x has to be going to 1. And now I'm basically done. Here's a pretty typical example. We're going to need to take the original expression and rewrite it as smaller fractions multiplied together. In this example, we need to take the tangent and re-express it in terms of sine and cosine in order to be able to isolate the pieces that we need to work with. Now I'm going to pull things apart so that we have three things multiplied together that are individually much more tractable. As before, we need to modify the factors involving sine so as to be able to actually finish taking the limit of each part. I need to both divide the sine of 3x by 3x and elsewhere multiply by 3x in order to balance the books on that first factor. Similarly, in the sine of 2x part, we need to both multiply in a 2x and divide by 2x elsewhere in order to fix it up. Now the limit of each fraction piece has been made obvious. And we can cancel out the x's at the beginning, and we can figure the limit as the product of the limits of each part. And there's our answer. I should also mention that you don't have to do all the algebra exactly the way I did it, but I will need for you to break things up into nice pieces where it is possible to take the limit of each part. I am going to assume that you know the very basic trig identities, which I will quickly list here. In particular, you have to be ready to make use of the identity sine squared plus cosine squared equal to 1 in various forms. Look at this example. Notice that if I plug in 0 for x, I get 1 minus 1, or 0 in the numerator, divided by 0 in the denominator. The only formulas that I know of that work for the trig functions where I have a division by 0 involve sine of x over x, so I have to figure out how to introduce pieces like that. The way I'm going to get this done is by multiplying the numerator and the denominator, each of them by the quantity 1 plus cosine of x. When I multiply out the numerator, I get 1 minus cosine squared of x. And this gives me my way of introducing the signs of factors that I need. I can now replace the 1 minus cosine squared of x with a sine squared of x. The sine squared x over x squared can be written as the quantity sine of x over x times sine of x over x. The 1 over 1 plus cosine of x fraction, as x goes to 0, is just going to go to 1 over the quantity 1 plus 1 over 1 half. Put this together and we have the limit is 1 times 1 times a half. So the limit is 1 half.